Okay, I'm a little burnt out on working on a record player, so I thought we'd work on an old radio. This is a Crosley 5er tombstone radio from around 1937. I picked this up at the flea market a while back, along with an Atwater Kent 82 cathedral radio that you'll see one day. This radio is in above average condition as far as what I find locally. In fact, I'm probably not going to do much of anything to the cabinet finish, just clean it and polish it and let it go. There's the back side. It looks pretty much complete except for a missing filter capacitor can, which is common. Generally, the old capacitor will go bad and the serviceman will just remove the old one and wire another one under the chassis. So I would at least like to find one to put back in its place, just so things will look better. I don't like holes on a chassis. Okay, here's a little trick I found to remove stubborn knobs. Of course, you could always take a screwdriver and pry them off, but you run the risk of damaging the knob as well as dinging up the cabinet. I just like to take a little piece of wire, finagle it behind the knob, and then pull on the wire, and then generally the knob will just come off without any damage. Just hook it like this, and in some cases, in order to gain access to the rear of the knob, you have to unbolt the chassis and sort of gently slide it back. That will also help work the knob loose, but you just pull on there like this, and you may have to tug and use one hand to hold the cabinet, but it will come off. So let me pause the camera a minute so I can hold the cabinet. Now we have all three knobs off with no new damage to the cabinet or the knobs or the control shafts. And here's our chassis and speaker. Now the dreaded moment when we flip the chassis over to see how many hack repairs have been done to it over the years. Well, the only obvious things I see are these replacement filter capacitors. They look to be from the 1940s. So I guess the first thing we'll do is attach a new power cord to this thing and then go from there. And look at how rotten this old power cord is. The ultimate in safety. Okay, we're almost done with the power cord. And you might notice I've replaced this chassis mounting grommet for the power cord. The original one was rotten. Instead of me tying a knot on the inside of the chassis, I've decided to obtain a cable clamp and just clamp this cord to the chassis right here. That'll prevent any kind of movement and prevent the power cord from being slid back up into the chassis. It'll actually be more secure than what it would be if I were to tie a knot off back here. And I should also still have room for the bracket that holds the speaker plug in place. Okay, before we begin recapping this radio, let's check the power transformer and make sure all of that's good. I'd hate to recap this thing and find that we have a bad power transformer. Okay, I'm testing across the power plug for continuity, and unfortunately there is none. So that indicates either an open power switch or a bad power transformer. I'm hoping it's just a dirty power switch, but that will be easy enough to check. Okay, it is the power switch. Before we go into panic mode, we'll spray some contact cleaner up into the switch and turn it off and on a few times and see if that solves the problem. Okay, unfortunately cleaning the switch didn't help, or at least not immediately, so I have it jumped with a clip lead, and we're reading 17 ohms across the primary of the power transformer. I have the rectifier tube removed to prevent the high voltage from coming up. Now we'll test the secondary windings of the power transformer and make sure they're putting out what they're supposed to. Okay, checking the high voltage at the rectifier tube socket. We have 300 volts from one side of the transformer to center tap. And we have 300 volts on the other side, so the high voltage winding is good. Now we'll check the 5 volt filament winding. And 5 volts on the rectifier filament, that's beautiful. And our other tubes are glowing at the brightness I'd expect them to glow, so that tells me that we have 6.3 volts on the other filaments. So unless this power transformer overheats while I have it plugged in, I'm going to consider it good, and then we can proceed with this. Checking the 6.3 volt winding, we have about 7.8 volts, which is about normal considering I have the output tube unplugged. If we were to plug the output tube back in, that should load it down to what it's supposed to be. And given the fact that we're running on about 120 volts input, whereas back in the old days 110 to 115 was the norm. And on the 1 amp scale, we're not drawing enough current to say we're drawing anything. So as far as I'm concerned, this transformer is good. So let's keep it that way. Okay, we have our rectifier tube installed. We're running about 60 volts AC input, making sounds, but our B plus is only about 50 volts. Under ideal conditions, I think it should be much higher than that. So we probably have some caps choking things down. Looking at these electrolytic capacitors, it appears that they only replaced one of them. They just have these two bridged together to substitute for the capacitor that was here, and the other electrolytic is still wired in place. Okay, here's our number 1 filter capacitor installed. As you can tell, I have it on a terminal strip here. It's not going anywhere. I like terminal strips, much neater than having parts dangling around. Now we've got this big filter capacitor we have to replace, and this one's going to be a little more difficult because look at all this stuff that's connected to this positive terminal on this capacitor. So we'll likely be using another terminal strip right here for that purpose. And one thing you never, ever want to do with these sets, and I've seen it done lots of times over the years, you never leave the old capacitor in circuit with a new capacitor bridged across it, because that old capacitor can short, and then it'll be all she wrote. I've actually seen it before. You want to disconnect the old capacitor from circuit, leave it in place if you wish for appearance purposes, but just make sure it's electrically disconnected. Okay, that was a total of 6 connections that were made to that positive terminal on the filter capacitor. And while we have it out, let's analyze the old capacitor as well as test these 2 resistors that were coming off of the capacitor, because if they're bad, might as well go ahead and replace them now. And this filter capacitor is wide open. Okay, we have our filter capacitors replaced. And I had to replace one wire because the original wasn't long enough to reach over to the terminal strip. I had to replace one resistor that had actually gone down in value. And I used heat shrink tubing to insulate everything, so it should be good to go. Something interesting about this power supply. First off, this uses a half-wave power supply. Most power transformer sets use a full-wave supply. And the second odd thing that was sort of kind of common in the 30s is the filter capacitors have a common positive, which means the positive connections are wired together, and the speaker field coil, along with some divider resistors that provide negative bias voltage, are connected between the negative ends of the filter capacitor. Okay, like I've said in the past, sometimes the better looking radios can be the most challenging. I found that the audio output tube socket on this set is cracked, which will have to eventually be replaced. I have it making contact right now, and this 350 ohm flexible resistor was wide open and just crumbled in my hand, so that's going to have to be replaced. That's in the bias circuit for the first audio tube. Okay, we now have the flex resistors replaced with modern carbon film resistors. These are the 2 that remained intact. The 300 ohm one crumbled on us. Now let's power this up and see if the condition has improved any. Well, we're motorboating louder than we were, and that's usually an indication of bad capacitors. Okay, I have most of the capacitors replaced. There's one I want to show you in just a minute. I have this AC line to chassis capacitor just tacked in because, like I said earlier, we're going to have to tend to this off-on switch, so I don't want to make that capacitor too hard to remove since we know that this has got to come out anyway. I also have this coupling capacitor to the output tube tacked on here because, like I said, this output tube socket has to be replaced, and we want to make it as easy as we can make it. Okay, let's turn it on and see if anything improved. Well, things improved, but we have a long way to go.
That can really electrify a crowd. So, you know what? It was my guess. And then they paid $19 billion for WhatsApp messaging service, which really doesn't operate in the U.S. It's very big overseas. And that's 356-6430.
Now, let me show you that capacitor that I did not replace yet. I noticed that someone had clipped one end of this condenser or capacitor loose, and I tested this capacitor and it's dead shorted. One end obviously connects here, the other end connects to ground. This is B+ voltage on the oscillator coil. So surely things will be better if we replace that instead of just leaving it clipped out. And here we are, 0.02 microfarad connected across the ohm meter. We're reading 1 ohm, so yep, this capacitor is shorted. And there it is. And since this is such a small capacitor, I was able to ground it right here, which is a lot easier than trying to fish it all back around over here and ground it. Okay, let's connect the antenna and see if any improvement has been noted. Okay, I really can't tell that any improvement has been made, but we've accomplished a great deal in this video. At least we have the radio playing. Next time we'll address these other issues, the bad off-on switch, the bad tube socket, and we'll get all this motorboating problem straightened out. This is just another example that just goes to show that capacitors are not the be-all, end-all. Yes, they need to be replaced, but there's usually other things that can cause problems too, and you have to be able to find those problems. Now we'll analyze these paper capacitors. Leaky, well, that might be the one that was dead shorted. Number 2, leaky, big time. Number 3, leaky, but not as bad as the rest of them, but bad enough to need to be replaced. Number 4, leaking like crazy. Number 5, yeah, you get the picture. Number 6, yeah, it's gone. And this one's also the one that was dead shorted. I think there's another one. Maybe it rolled off on the floor. Let's see if I can find it. Well, number 7 has lost itself in the black hole of the shop floor, but who cares? We know it was most likely just as bad as the rest of them. Okay, that ought to take care of it for part 1. And part 2, we'll address this tube socket and the off-on switch and any other problems we might have. Okay, there you go. Thanks for watching, and more to come later. Okay, one last thing. This resistor that goes from the screen grid of the output tube that provides plate voltage to the driver stage is supposed to be 300K. It reads something like 520K ohms, so I did go ahead and replace that. All the other resistors appear to be okay. Okay, there you go. More next time. Well, I think replacing that resistor helped some. I like to end videos on a positive note.